Today we're here to explain pain. So pain is useful. Pain is how our brain tries to protect us. It's the message that our brain sends out to our body whenever it thinks that we're in danger. So let's say here we have a nail that is sticking into our finger, causing us to bleed over here. Our helpful little sensory receptor or nociceptor right here sends the message into the dorsal root ganglion, or this place right next to your spinal cord where the cell bodies of the nerves are kept. And it sends that message up here to your brain, and the brain perceives a threat. It says, oh, we are in danger. The brain then sends out another nerve or several nerves out towards the periphery, out towards different areas in the body, activating your immune system, activating your endocrine system, activating all these wonderful, amazing supporting systems in your body that help you to have the response you need to appropriately fight off potential infection or alter movement or do anything else that your body needs to do to protect you. So pain is useful. Pain helps to protect us. However, sometimes the pain's not really protecting us at all because there's nothing to protect us from. So let's take it over towards our hand on the left-hand side here. In this hand here, there's no nail in the hand. In fact, there's no tissue damage at all in the hand. Yet the brain is sending down the signal into our body telling us, oh, there is pain here. We really should guard our hand. Ooh, that really hurts. Don't do that movement. So why? Why do we feel this pain here even though there's no actual threat? And in fact, this happens quite often, especially in people with low back pain. There's been research showing that for many people, the pain that they're feeling isn't correlated with the X-ray findings they have. And conversely, people with X-ray findings or MRI findings showing bulging discs or compressed nerves might never have any symptoms at all. So if tissue damage, this damage in the low back structures, is not necessarily correlated to the pain experience, what's happening here? Lorimer and Moseley describe pain as the neuromatrix model. They explain how there are several areas in your brain, such as your amygdala, your anterior cingulate gyrus, your hypothalamus, your hippocampus, your thalamus, your prefrontal cortex, and other areas that also have a reaction to how you should be feeling pain. So this brings in your emotions. This brings in your experience. And together, these areas of the brain interact with each other, much like telephone wires, all going back and forth with each other. And they send a signal down to this dorsal root ganglion, and they modify the input from your periphery. So say that this nerve in your hand was coming in, and it's like, we're totally fine. We're not feeling any pain. But these head honchos up here from the brain are sending down the signal like, I don't know, last time it was really cold out, our hand hurt. I think our hand hurts. I think our hand hurts. And suddenly we're perceiving pain. So it's not just about what happens in the periphery. It's also about what the brain expects to be feeling. So guess what? It is, in the case of pain, all in your head. But the thing is, it's still real. It's still a very real part of your experience. But it just means that when we're targeting intervention for chronic pain, we might need to start with the brain.